Have you ever stopped to wonder why that 2-hour movie you're streaming to your phone doesn't, take up your entire hard drive? It seems like it should, right? Well, today we're going to dive into exactly that. We're pulling back the curtain on the fundamental math that makes all of digital video even possible.
To figure this all out, we have to start with a really simple question. What is a video file, really? I mean, what is it at its absolute most basic, raw, uncompressed level? Well, the answer is way simpler and at the same time much, much bigger than you probably think.
To understand the big picture, we've got to start with the smallest possible piece. We're talking about the absolute atom of an image.
And it all begins right here, with the pixel. Its name literally means picture element. And that analogy on the screen is perfect. Think of it like one single, tiny tile of color in the giant mosaic that makes up your screen. Absolutely everything you see is built from millions of these little guys.
So how does that tiny tile get its specific color? Well, it's actually a really simple recipe using just red, green, and blue light. We just define how intense each of those three colors is, and we can create millions of different shades. But that color information, it takes up space. Each color gets 8 bits of data, so you add them up, and you get a grand total of 24 bits, or an easier way to think of it, 3 bytes for every single pixel. Now remember that number, 3 bytes. It's going to be important.
Okay, so let's zoom out a little. If a pixel is a single tile, then a frame is the entire finished mosaic. It's one single, still image, a complete grid made up of all those millions of individual pixels, each one holding its own specific color information.
I'm sure we've all heard the term 1080p or Full HD, right? Well, all that's really describing is the size of this grid. It just means the frame is 1920 pixels across and 1080 pixels down. Simple as that.
So if you do that simple multiplication, you get this. Over 2 million pixels. That's 2 million tiny dots. And remember, each one needs its own 3 bytes of color data just to create one single static picture. We're not even at the video part of video yet. And this is where the magic really starts to happen. See, a video is just a series of these frames, these still images, shown one after another, really, really fast. It's exactly like one of those old flip books. Your brain smooths out the gaps between the pictures and sees it as fluid motion. And the speed at which we flip the pages, that's called the frame rate.
And that rate changes depending on what you're watching. 24 frames per second, or FPS, gives you that classic, dreamy, cinematic look for movies. 30 FPS is the standard for broadcast TV. And 60 FPS gives you that ultra-smooth, crisp motion you see in sports and video games. For our little calculation, we're going to stick with that standard 30.
Okay, so we have all our building blocks now. We've got the pixels, we've got the frames, we've got the frame rate. Let's put them all together and do the math. And you might want to brace yourself for how big these numbers are about to get.
First up, let's figure out the size of a single frame. We take our 2 million plus pixels and we multiply that by the 3 bytes of data that each one needs for its color. The result is about 6.2 megabytes. That's like a high-quality photo for every single frame.
But a video isn't one frame, right? It's 30 of them every second. So we multiply that 6.2 megabytes by 30, and now we're at 186 megabytes for just 1 second of video. You can already see where this is headed, can't you?
Okay, let's scale this up to just 1 single minute. We take our 186 megabytes per second and multiply it by 60 seconds, which gives us 11,160 megabytes. And that translates to 11.16 gigabytes for 1 minute of standard Full HD video. Just think about that for a second. A single 60-second clip would be bigger than many apps, bigger than most games, maybe bigger than your entire photo library.
So we've got this absolutely massive number. And this is way more than just a fun fact. This is the fundamental problem that the entire video industry has been built to solve. This is the 11 gigabyte problem. And let's break down why it matters so much.
This brings us to a really critical conclusion. Raw, uncompressed video is just too big. You couldn't download it, you couldn't stream it, and you certainly couldn't store very much of it. It's just completely impractical.
How impractical? Well, if we take that 1-minute calculation and scale it up to a typical 2-hour movie, you're looking at 1.3 terabytes. Your average laptop might have a quarter of that storage space in total. This one single file wouldn't just fill up your hard drive, it would need 3 more just like it.
Which, of course, brings us all the way back to our very first question. How do you fit a 1.3 terabyte file into your pocket and stream it over Wi-Fi? Well, the answer isn't actually magic, but it is pretty close. It's the incredible science of video coding and compression, the invisible engine that makes our entire digital world possible.